Hi everyone, this is Chris Olson with the ArduPilot organization, and I'm going to be doing I think probably 3 videos on setup of a traditional helicopter with the ArduPilot flight stock. And the first video, I think we're going to look at the basic settings and what is specific to helicopters and explain what they do. And the second video, I think we'll be looking at basic head setup, servo setup, tail servo setup, throttle servos, and so on. And finally, with the third video, we'll be looking at how to set up the rotor speed control system or the throttle control system with the ArduPilot system. So starting off with the first things that we're going to be looking at here. When you make settings to a helicopter, we always recommend using the full parameter list or the complete parameter list in your software. In this particular instance, we are using Q ground control on an Android tablet. A lot of folks will be using Mission Planner, and Mission Planner has a lot of extra tuning pages, extended tuning pages, as well as APM Planner 2. And with helicopters, basically kind of try to stay away from those. Those are designed for multi-rotor type aircraft, and they can tend to be a little bit too helpful sometimes and make settings to your helicopter that are not desirable. So if you stick to using the full parameter list or the complete parameter list in your ground station software to make the settings, it should be pretty straightforward, and you should not get settings that aren't desired in your setup. I'm not able to demonstrate this with Mission Planners. I'm not a Windows user. I use either APM Planner 2 on Linux or Q ground control or Tower on the Android tablet. So we're going to demonstrate this with Q ground control. And the first thing that you want to do, radio calibration is very important. Make sure that you calibrate every channel in your radio to its full range. 8 channels minimum are required to fly a helicopter with ArduPilot. You can fly a helicopter with the, say like the Pix Racer, which has 6 servo outputs, but it still requires 8 RC inputs to fly that helicopter with ArduPilot because the throttle control is on channel 8. So do your RC calibration and make sure that all 8, 10, 12, 14, 16, 18 channels, whatever you have, make sure that all channels in your radio are calibrated to their full extent. And also, before you start doing any setup, and this is pretty much the same as multi-rotors, do the accelerometer calibration, and I do recommend doing the compass calibration before you start as well. The accelerometer is best calibrated with the flight controller on the bench before you install it in the frame. Some helicopters are pretty big. The particular helicopter that we're doing this demo with has a 1.8 meter diameter main rotor, and it weighs a little over 10 kilograms. So, you know, when you're handling a helicopter, you have to tip it on its nose, on its tail, on its side, and so on. And having that big main rotor in the way and handling a heavy helicopter can be kind of difficult to handle.
EKF primary change 1.
And try to press buttons on a computer screen at the same time. So the accelerometer calibration is best done with the unit out of the frame, and then install your pixhawk in the frame.
EKF primary change 0.
Compass calibration is not absolutely required.
EKF primary change 1. EKF primary change 0.
Okay, we can quit the EKF stuff here. We don't have a GPS lock in the shop anyway. The compass calibration.
EKF primary change 1. EKF primary changed 0.
The compass calibration is not absolutely required to do the helicopter setup, but I think it's a good idea to install your compass and calibrate the compasses anyway before you start. The helicopter specific parameters all start with H, and most of the ground station software applications are going to have a search box, so if you just type in H underscore, all of the H specific parameters or helicopter parameters should come up on your screen. Let's go through each one of these and look at what they do and try to explain these. But before we start setting the H params, there's a couple extra params that should be set. I kind of like to set these. One is the board safety enable. This is the button or the safety arming switch. I think it's a good idea to disable that for at least for setup. If you wish to enable that later, that's fine. But for setup, I think I would recommend disabling it, because we have had reports from users where that continually kept disabling the servo outputs and made it difficult to set the helicopter up, and they couldn't figure out why the servo output stopped working. So I recommend setting that board safety enable to disabled, which in Mission Planner I believe you'll have to enter 0. This particular software is pretty nice. It uses regular English, enabled or disabled, so disable that one. And the other one is the disarm delay. Which is this one right here. Set the disarm delay to 0. This will be important for setting up your throttle servo for a combustion engine helicopter, because otherwise it's going to keep disarming and disable your servo. And typically with helicopters we do not use a disarm delay anyway, because it does not allow you to idle a helicopter with a combustion engine in it. So disable that one by setting it to 0. Now going back to the H specific params, the first one here, the call yaw, is a collective yaw torque compensation. And what this does is, say you're in hover and you suddenly feed in some collective pitch to climb, the torque created by the additional lift from the main rotor is going to cause the frame to want to yaw. And this provides a feed forward path to the yaw servo to help prevent that tail kick that you get when you feed in collective very quick or drop collective very quick. Otherwise the system has to wait for a change in the heading or sense angular acceleration in the yaw axis and then correct it, so you're going to get that tail kick. This feed forward from the collective yaw torque compensation can help prevent that. Positive values are for a clockwise turning rotor. Negative values are for a counterclockwise turning rotor. And the software we're using, by the way, is it is ArduCopter 355. This happens to be a special build, which is a development build. So you're going to get a chance to preview some of the changes you might see coming out in 3.6 here. But this is all based on ArduCopter 3.5. The next parameter here, collective max. This is pretty much self-explanatory. It sets your maximum collective pitch. The call mid is the 0 collective pitch parameter, the one you use to set 0 collective pitch. The call min is the minimum collective pitch in the collective pitch range. So these three are pretty much self-explanatory. The cyc max is your cyclic max pitch, and this is set, I believe, in Mission Planner. This is going to be in centi degrees, so this will probably be like 2500. here in the Q ground control software, it uses again regular things that people understand, so it says 25 degrees, but I believe that 25 degrees is the actual tilt angle of the swash plate, and it sets your maximum cyclic pitch. Flybar mode is pretty much self-explanatory. You either have a flybar or you don't. The gyro gain is for the tail gyro. If you have an external tail gyro, this is the gain value that will be sent to your gyro on channel 7. This is the same thing here except for acro. So you can have two different gains sent to your tail gyro depending on whether you are in acro flight mode or one of the other flight modes. The land collective minimum setting is the setting that the system uses to determine where or when the helicopter is landed in autonomous flight modes. So if you're doing an auto landing, the system can reduce the collective pitch to that value, and the rest of the system doesn't sense any further descent or any further movement of the helicopter, and the collective pitch is at that value. It assumes that the helicopter is landed, and it disarms and shuts the engine down. Now, obviously this is a very important one to get right, because if you set this too high, the system can drop the collective pitch to whatever that is set to, and if it's still not landed, it can cause it to shut down in flight and make a rather rough landing. So that's an important one to get right. The phase angle is a compensation for, say you have a helicopter where you feed in some forward cyclic pitch, for instance, and it causes the helicopter to roll one way or the other because of a phasing issue with the swash plate. That can be corrected with this particular parameter. The RSC parameters are, RSC stands for rotor speed control, and the critical setting is the throttle setting below which flight is not possible. So this is also an important one to have right, but basically whatever throttle setting that your helicopter absolutely cannot fly at, that's what this should be set to. These next two are parameters that are not in the current stable release or in 3.6 dev yet, but I will be doing a PR on those to put that feature into 3.6, so we'll skip over those for right now. The idle speed, the rotor speed control idle, is the setting that a combustion engine needs to idle. That is not used for electric helicopters. That is for combustion engine helicopters. Well, both piston and turbine helicopters require a setting that will let the engine idle without the clutch engaged, and that setting becomes active as soon as you arm the flight controller so you can start your engine. Not used with electrics. The RSC mode, we will be covering these in a third video on how to set up the various. There's 3 different modes. We'll cover how to set those up. But this is your throttle control mode. The rotor speed, ramp time, and run-up time. The ramp time is the time when you engage the motor interlock. In ArduPilot terms, in helicopter terms, you would be disengaging the throttle hold. The ramp time is the amount of time the system takes to go from 1000 PWM on the throttle output to whatever your throttle setting is. The run-up time is the amount of time it takes for the head to actually reach the speed that you have it set at. So run-up time must always be set at least 1 second longer than ramp time. The rotor speed control set point is used with a mode 2 throttle control, and that is your throttle setting for a mode 2 throttle control, and again we'll cover that later. The slew rate is the rate at which your throttle signal can change over 1 second. And this is explained right here in the software. It controls the maximum rate at which the throttle output can change as a percentage per second. So set to 0, it allows unlimited change. You can set that to allow limited change in your throttle servo output. These next 5 parameters are again parameters that are not in the current stable release. This is a mode 3 5-point spline throttle curve, which we hopefully will have coming out in 3.6. But in the standard release, these 5 parameters are actually just 3 parameters for a collective high, a collective low, and a collective negative setting for a throttle curve in the software. So again, we will cover those later. The servo positions, and these are kind of out of order here, but the swashplate type, you have to make sure that you select the proper swashplate type for your helicopter. This particular helicopter is using a 3-servo CCPM, and we have either that choice or H1 mechanical mixing. So make sure you select the proper swashplate type, which is typically going to be a 3-servo collective cyclic mixing system. Your servo positions are quite important to get right. Servo number 1 on this particular helicopter is the left front servo. Servo number 2 is the right front servo. And this is the pitch and aileron servos respectively. The elevator servo is servo number 3. So the standing at the rear of the helicopter and drawing an imaginary line through the nose of the helicopter with 0 degrees being to the front. The servo number 1 is at a position of minus 60 degrees. Servo number 2 is at positive 60 degrees from that imaginary line going through the center line of the helicopter, and the third servo is at the rear. The elevator servo is at the rear at 180 degrees. And this may be different for different helicopters with different types of swash plates, so make sure that you set your servo positions to correspond to what your swash plate actually is. The servo manual setting is used for setup only, and we will be looking at that when we do the head setup. The servo test function is a function that that cycles your servos through their full travel of both cyclic and collective pitch. And it does this on boot up so that you can see whether or not your servos are binding and make sure all the servos are working properly. And it will do a cycle with the collective at the bottom, and then it will do another cyclic pitch roll cycle with the collective at the top, and then return to center. And you can set that for as many of those cycles as you want to do at boot up time. This particular parameter here is another one that is not in the current stable software, nor in 3.6, but again, that's a feature in this custom build here, so we won't cover that one right now. Swash type we looked at. The tail speed is the speed setting sent to the ESC on a helicopter that uses a direct drive variable pitch tail. So you have an electric motor driving the tail. You want that tail rotor to run at a constant RPM, and you use a servo to control the pitch on the tail assembly. This parameter right here sets the speed of that tail rotor. And then we have the tail type. There are basically 4 different tail types here. Servo only, which is a mechanically driven servo steered tail. Servo with an external gyro, which we were talking about earlier with the external gyro parameters, which you may use if you use a downstream flybarless unit with your pixhawk. We have a direct drive variable pitch tail and a direct drive fixed pitch tail. And the direct drive fixed pitch system actually throttles a tail motor just like a propeller on a multi-rotor does for yaw control. So the type of tail your helicopter has must be selected with that parameter. The other ones we want to look at for a helicopter are the servo parameters. Let's see what we got here. Servo 1. Again, this is your front servo. Make sure that that function, the servo 1 function, is set to motor 1. And again, in Mission Planner, this will be a number. I believe it's 32. But make sure that that function is set to motor 1. Servo 2 is set to motor 2. Servo 3 to motor 3. Servo 4 to motor 4. This is your tail servo. And way down here at the bottom, servo 8 should be set to heli RSC, which I believe is numerical function 31. I think, without looking up the actual numeric values of these various parameters here, but I think that is a 31, and that should be set to the heli RSC for your throttle control. Well, we won't cover direct drive variable pitch or direct drive fixed pitch tails right now. The servo 7 function is going to be set to supply the signal to a direct drive variable pitch tail motor, but we won't cover that for the purposes of this setup. That's more of an advanced setup, really. And then the final thing is flight modes. Make sure you set up your flight mode before you start setting up your helicopter, and make sure that stabilized flight mode is one of those modes that you have set up for your flight modes. You can set the rest of them up to whatever you want, but make sure that stabilize is at least one of the flight modes that you have set up. So I think that pretty much covers the things that are specific to helicopters. One thing that's different between helicopters and multi-rotors is on the radio, the RC8. Let's see here. Well, I guess we have to go to the advanced RC to see this. Your RC8 on the helicopter is what controls the throttle, and the first 4 channels, RC1 through 4, are pretty much the same as a multi-rotor. You have the left stick, you have rudder and collective. Now, in a multi-rotor, that's going to be called throttle. In a helicopter, get used to calling that collective. So you have rudder and collective on the left stick. You have pitch and roll control or cyclic control on the right stick, and those are channels 1 through 4, and that's pretty much the same. But channel 8 is the one that controls your throttle, and make absolutely certain that you have that channel calibrated right to its full range when you calibrate it, or you will have problems with the ground station complaining about the motor interlock being raised. So that is one thing that's kind of unique or different about ArduPilot, is it's handling the throttle control in a helicopter on channel 8. In most traditional fly-barless setups, throttle controls on channel 3, collective pitch controls on channel 6. In ArduPilot, collective pitch controls on channel 3, throttle controls on channel 8. So that's an important one to make sure that it's calibrated right. So I think that pretty much covers the basic settings for helicopters that need to be made, or at least double checked, before we start the mechanical setup of the head. Thanks for watching. We will come back with video 2.